A pleasant day to everyone. For today's lesson, we'll be talking about logistic equation. Alright, but before we dig into our main concern in this lesson, let us review first the population growth model, wherein it is the rate of the population with respect to time that is proportional to the current value of the population with k in here, as the constant to proportionality, wherein it is positive because k should be greater than 0. Well, in this equation, it describes a short term. It is a pure growth only, has a low resolution model because it ignores competition, carrying capacity, harvesting, and etc. Now, let us enhance our population growth to incorporate some information to make it more realistic. We let K as f of P. Well, this model are based on the density dependent hypothesis, which assume that the rate of change in the population is dependent on P only and not on T. So we substitute, we have this differential equation dp over dt is equal to p times f of p, which is now the function. Alright, however, uh, all we need for the function that will satisfy those condition, well, daghan tag mahimo nga function, but ang pinakasimple is that would satisfy all the points is making it a linear function. So the form of the linear function is f of x is equal to mx plus b, wherein we are going to let x as p and b is equal to r. Now we have f of p is equal to mp plus r. Now let us review the formula of the slope, wherein m, supposedly we know it is the slope, so y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Wherein now we are letting k, capital K, as the carrying capacity. Thus we have f of k denotes that it is equal to 0, and then f of 0 is equal to r. In this case, we're letting the value of x sub 1 is equal to k and our y sub 1 is equal to 0, and then x sub 2 is equal to 0, and then y sub 2 is equal to r. Thus, we are equating it into 0. So let's substitute everything. We have m is equal to r minus 0 all over 0 minus k is equal to r over negative k. Therefore, we are having a slope of negative r over k. Now let's substitute in this function. F of p is equal to negative r over k times p plus r. In this case, we let this function now be substitute the value of f of p. So we have this differential equation as dp over dt is equal to p times f of p, or negative r over k times p plus r. Alright, so let's rearrange. We have dp over dt times is equal to p times r minus r over k times p. Now, as I've said, k as the carrying capacity. So ato ang i-remodel ang kaning differential equation to make it more logistic model that applies more than just a population growth. We let r is equal to a to make it standard, and then b is equal to r over k. So we have now this equation as dp over dt is equal to p times or quantity of A minus BP. Now this equation is what we call a logistic equation. So we have dP over dt is equal to P quantity of A minus BP. This equation is autonomous, wherein an equation which the right side is a function. So it is separable. We can find the general solution by using separation of variable. Okay, wherein the critical point solutions are p is equal to 0 and p is equal to a over b. Alright, as what I've said earlier that the logistic equation is separable, so we can easily solve it by means of separation of variable. Okay, so let's separate the variable. We have dp all over p quantity of a minus bp is equal to dt. Now let's integrate. Now the interesting part in here is the left side. So makita na to somehow complex, but the correct approach that we are going to use in this side is the partial fraction decomposition. So applying the partial fraction, we have the integration of quantity 1 over a all over p plus b over a all over a minus bp dp is equal to t plus c. And then we have the integration of, let's separate the integration. So we have the integration of 1 over a all over p dp plus the integration of b over a minus bp dp is equal to t plus c. So we have, now we can integrate this equation. So we have 1 over a ln absolute value of p plus b over a times negative 1 over b ln absolute value of a minus bp uh, equals t plus c sub 1. Now we're equating c is equal to c sub 1. Alright, now let's multiply both sides by a. So and simplify. So we have ln absolute value p minus ln a minus bp is equal to at. A times t is at plus c sub 2, wherein c sub 2 is equal to a times c sub 1. In this case, applying the law of natural logarithm, so we have ln, the absolute value of p all over a minus bp is equal to at plus c sub 2. And then insert e, or the Euler's number, applying the property of Euler's number. So we have, applying the law of natural logarithm. So we have the absolute value of p all over a minus bp is equal to e raised to 80 plus c sub 2. And then applying the property of Euler's number. So we have uh, p all over a minus bp is equal to e raised to 80 times e raised to c sub 2. And in this case, we're letting the value of c sub 3 is equal to e raised to c sub 2. And then we have the absolute value of p all over a minus bp is equal to c sub 3 times e raised to 80. All right. And then we have p all over a minus bp is equal to c sub 4 e raised to 80. Wherein our c sub 4 in here is equal to the positive and negative of the constant value of c sub 3. Wherein we can equate it also as our 0 because our p is equal to 0 is one of the critical solution or one of the solution. Now, para ma-isolate natong p, okay, we bring the denominator into the other side. So And now we're going to multiply and simplify both sides by a minus bp. So we have p is equal to quantity of a minus bp times c sub 4 e raised to at. And then let's distribute the right side. So we have p is equal to a c sub 4 e raised to at minus bp c sub 4 e raised to at. And then let's add both sides by bp. Okay, c sub 4 e raised to at. So we have p plus bp c sub 4 e raised to at is equal to a c sub 4 e raised to at. And then let's factor the left side. So we have p quantity of 1 plus b c sub 4 e raised to at is equal to a c sub 4 e raised to at. And then let's divide both sides by 1 plus b c sub 4 e raised to at. So let's simplify. We have p is equal to a c sub 4 e raised to at all over 1 plus b c sub 4 e raised to at. We're equating c sub 4 as c, since I guess it's the last constant we have. Therefore, we are having this equation p is equal to ac e raised to at all over 1 plus b c e raised to at. And then let's multiply both sides by e raised to at. And let's simplify. So we have p is equal to ac all over e raised to at plus bc. And let's rearrange. All right, now this is our solution. So we have p is equal to ac all over bc plus e raised to negative at. So gi-rearrange na to. Then, as I've mentioned earlier, that the value of one of the critical solution is p is equal to ab. Now, in this case, it's really unsatisfying the a, b, and c in here. So we have this condition. So we're letting this condition p of 0 is equal to p sub 0, and then our p is equal to p sub 0, and our t is equal to 0. Now, by that given condition, we may be able to determine the value of our c. So we have here the solution, p sub 0 is equal to ac all over bc plus e raised to negative at. Now let's substitute the value of our t. So we have p sub 0 is equal to ac all over bc plus e raised to negative a times 0, any value multiplied by 0 is equal to 0. So we have e raised to 0, probably 1. So we have p sub 0 is equal to ac all over bc plus 1. So multiply both sides by bc plus 1. So we have p sub 0 bc plus 1 is equal to ac. Now let's distribute and multiply. So we have p sub 0 times bc plus p sub 0 is equal to ac. And then let's subtract both sides by p sub 0 times bc. So we have p sub 0 is equal to ac minus p sub 0. And by that, let's factor out c from the right side. So we have p sub 0 is equal to c, quantity of a, minus uh, b, p sub 0. And by this, let's divide both sides by a minus bp sub 0, and let's interchange the sides. So we have now the value of our c is p sub 0 all over a minus b p sub 0. Alright, now going back to this previous solution, now let us substitute the value of our c earlier. So We have this A quantity of P sub 0 all over A minus B P sub 0, the value of RC, all over B quantity of P sub 0 all over A minus B P sub 0 plus E raised to AT. And to simplify that one, we have P is equal to A P sub 0 all over A minus B P sub 0 all over B P sub 0 over A minus BP plus E raised to AT. And uh, let us multiply both sides by E raised to AT and now let us simplify everything. So we have P is equal to A P sub 0 all over B P sub 0 plus the quantity of A minus BP E raised to negative AT. And this is our solution after a long process. So we have now the solution of our logistic differential equation subject to P of 0 is equal to P sub 0. All right, that's it. And now let us proceed to the example. So consider this given problem. Suppose a student carrying a COVID-19 virus returns to an isolated high school campus of 1,000 students. Okay? Determine a differential equation for the number of students x of t who have contracted the virus if the rate at which the disease spreads is proportional to the number of interaction who have the virus and the number of students who have not yet been exposed to it. Where our t is in days, okay, that's the unit of our time. Thus, in 7 days, there are 50 students have the virus. Now the question, here's the main question. When will 500 students have the virus or half of the population? That's the question now. So by this, we're having x of t as the number of the student who have contracted the virus, right? The said virus. Since it is given in here, okay, determine there's the number of the student, right? X sub t. So that's it. Now, let us think of a situation nga wala pa exposure. Okay? Wherein it is subjected to x of 0 because our time in here is 0. Okay? Is equal to 1 because nagsugod man siya sa isa ka contracted student. Now, let's remember the logistic equation. So, we have dP over dt is equal to P quantity of A minus BP. That's our logistic equation. Now, to consider this logistic equation relating to the problem, so we are making an equation of dx over dt is equal to k times x quantity of 1000 minus x. Okay, we're in our p in here, okay, is equal to x. Now let us distribute the k in the inside. We're in our k in here is the carrying capacity. So to distribute the k, so we have dx over dt is equal to x quantity of 1000 k minus x times k. Now, to relate to our logistic equation, thus we are having the value of our A is equal to 1000 K and our B is capital K. Yet, X of 0 is equal to P sub 0 or the initial, and the initial population is 1 because there is only one contracted student at the very beginning. All right. So the solution of our logistic equation is this. P is equal to A times P sub 0 all over B P sub 0 plus quantity of A minus B P sub 0 times e raised to negative at. We're in the solution of the logistic equation subject to p of 0 is equal to p sub 0, or the initial population. Now in here, the p value is equal to x of t. Okay, mauna ang ato ang gi-mention kaganiha. So in this case, substitute lang nato. So we have x of t is equal to a p sub 0 all over b p sub 0 plus quantity of a minus bp sub 0 times e raised to negative at. Now, the previous values, substitute nato. Okay, so let's go back to our logistic equation, formulated logistic equation. Thus, we are having the value of our A and B, okay, as well as the initial contracted population. Nagsugod naman to sa isa ka estudyante. Right, now this time to have the solution, okay, considering the problem, let us substitute the value of our A and our B. And now let's have this solution and substitute the value of our A, B, and P sub 0. So we have the value of our A, 1000K, and our P sub 0 is 1, and B is equal to K. So let's simplify. We have 1000K all over K plus quantity of 1000K minus K times e raised to negative 1000K times t. So let's simplify. The denominator, we have 1000K all over K plus 999K times e raised to negative 1000K times t. And let us factor out the k. So by this, we have 1000K all over K, quantity of 1 plus 999 e raised to negative 1000K times t. By this, we're able to cancel out, okay, since K divided by K is 0. So, kanisa cancel. So, the only remaining is this solution. So, we go up to this solution. X of t is equal to 1000 all over 1 plus 999 e raised to negative 1000 k times t, where t is in days. Okay, consider naton nga statement. Thus, in 7 days, there are 50 students have the virus. Okay, now the value of our t is 7, and x of t nato is 50 na. Okay? So, ang time nato is in 7 days man. And our x of t is 50. So, na 50 student contracted the virus. Alright. By that, let us substitute. So, from this solution, substitute nato ang values are to ang x of t and our t value. So, we have 50 contracted student is equal to 1000 all over 1 plus 999 e raised to negative 1000k times 7. Now let's multiply the denominator, simplify. So we have 50 is equal to 1000 all over 1 plus 999 e raised to negative 7000k. By this, let us multiply both sides by 1 plus 999 e raised to negative 1000k and simplify. So we have this equation, 50 quantity of 1 plus 999 e raised to negative 7000k is equal to 1000, and simplify na to. So by this, simplify, divide na to both sides by 50. So 1000 divided by 50 is 20 as the right side, and this is now our equation. By this, let's subtract both sides by 1. So we have 999 e raised to negative 7000k, okay, is equal to 19. And let us divide both sides by 999. So only remains is e raised to negative 7000k is equal to 19 over 999. And let us apply the law of uh, natural logarithm. So by this, we are having negative 7000k is equal to ln of 19 over 999. So by this, let's divide both sides by negative 7,000. So this is now the value of our k. Okay? So the value of our k is negative ln 19 over 999. Okay? Over 7,000. So negative ln 9 of 19 over 999 all over 7,000. That's the value of our k. So by this, we may able to find the main question. When will 500 people or 500 contracted students have the virus? Okay? So, ang gipangutan na jud diri is time since we are talking about when. Kanus. So, sa x of t na to is 500 kay mao man ang gipangutana. So, kanusa ka na may tabo? That's the question. So we have this solution, x of t is equal to 1000 all over 1 plus 999 e raised to negative 1000k times t. Okay? So atong x of t is 500 and our t is the missing. We have already the value of k. We're in negative ln of 19 over 999 all over 7,000. So let us simplify. So we have 500 is equal to 1,000 all over 1 plus 999 raised to t over 7 ln 19 over 999. By this, gisimplify lang nato. Okay? So, ang kaning 1,000 o 7,000. Okay? Negative 1,000 over 7,000 is 1 over 7 times negative 1 times t is negative t. Wherein it is also multiplied since negative man po ang na sa parenthesis. So, still positive na siya. Right, now let us simplify. So, kani siya, cancelled out. Multiply both sides by 1 over 500. Okay, kani siya, 1,000 divided by 500 is, mahimo na ni siyang 2. Kunya, kani siya, mahimo dari is 1 na lang. So, we have 1 is equal to 2 all over 1 plus 999 e raised to t over 7 ln 19 over 999. So let's multiply both sides by the denominator of the right side. So it will become 1 plus 999 e raised to t over 7 ln 19, okay, over 999 is equal to 2. So let's subtract both sides by 1. So it will become 999 e raised to t over 7 ln of 19 over 999 is equal to 1. And let us divide both sides by 999. So the remain, or it will remain sa e raised to t over 7 ln of 19 over 999 is equal to 1 over 999. Applying the law of natural logarithm. So Engage na to ang natural logarithm. So we have t over 7 ln of 19 over 999, okay, is equal to ln 1 over 999. And let us divide both sides by uh, ln 999 over 7. Or we can also cross multiply. Okay? So para ang mabilin sa left side is just t. So by this, we may able to identify the value of our t, and kung i-compute na to na sa calculator, i-input na to sa calculator, so we have the value of our t approximately, okay, when will 500 people have the virus? That's our question. So the value of our t is approximately 12.2 days. So that's the answer of the question, applying the logistic equation. All right, that's it. Our example for today. And as our ending, okay, we have this as your homework, and please answer this as your exercise. All right, that's it for our lesson for today, and God bless everyone. Bye.